All right, so how does this work? And how would you make such a fluid? So I think there's three major properties that you'd like to have for a ferrofluid for bioheating purposes. First of all, you like to have small particles. Second of all, you like to have magnetic particles because you want to use the magnetic field. And third, you want to have some biocompatible particles. So all these things come together to make our magnetic ferrofluid. So let me talk about these in turn. So first of all, small particles. What do I mean by small? And why would we need small particles? So just to give you some sense of how small these are, this is a scale here. This is in nanometers. So you can see here we start off on the right-hand side. We have a tennis ball. It's about 10 to the 8th nanometers. Here's a period at the end of a sentence. That's about 10 to the 6th nanometers. Get down to the size of cells, cancer cells, about 10 to the 4th nanometers. And then you get down to things that affect cells, things like viruses and bacteria and antibodies. And this sort of sweet spot here then is down here, roughly between 10 and 100 nanometers is what most people have been pursuing in the nanotechnology industry. And there's a whole set of things you can make in this range. We're going to be focusing on sort of nanoparticles. And so I think here that not only does it using sort of biological analogies that small things like viruses can affect cells is a compelling reason, but also that these nanoparticles also have interesting properties. For example, when you go down to very, very small particles, these particles have a much higher, say, surface to volume ratio than bulk particles would. And so, for example, then if you heat them up, they're going to rapidly transfer their energy to the surrounding environment, which is what we would want for these cancer treatment applications.